Well, today I'm gonna explain how this parallel parking method works, and this is just for academic purposes. First, let's let's think. Uh, we got a parking slot and two cars already parked, so we have to align the rear axle of our parking car to the rear bumper of the car that is already parked. So in many videos, there is a recommendation to align the both rear bumper. It doesn't work like that in this method. In this case, we should to align the rear axle to the rear bumper, and also I define the car box for a future measurement I will show. Then this car box is about to define the space for fixing our car in the parking slot. So we uh, we begin with moving with the steering wheel to the full about an alpha 1 angle turning. After that, the pivot of the turning change offside, and now we'll move the alpha 2 angle, and after that an alpha 3 angle. Finally, we will center in the parking slot to get in correct position. This method already works. I try with a few cars and it already works. Well, what are the main parameters? One of that is this length of a space. Is the space enough for the parking? Well, the that distance is given by this formula, and the parameters I will show you in the next moments. I found in my calculation that in most of the cases, L is about 1.4 times the total car length. It's 1.4 times bigger than the length of the car. And I did not try for so many cars, but I try a few and I found there's a value about 1.4. I will show you. Another parameters taken are the width of the car and no mirrors taken, the distance between the axle and the front bumper, the distance between axes, and finally the rear axis to the rear bumper. So also I need to take this angle phi of the inner wheel. If the pivot point of the turning is about this side, I must take this angle or the angle phi of this wheel. I know this angle is different, but I mean this, only this one. Also, I need to calculate this distance to the side of the car, not the middle of the car. I need the distance of the side of the car and this angle. I know the angle phi is about 44 degrees in many cars, but I made the measurement on my own car and I get is 42 degrees, and I do the same with other cars from my friends, and I found it's about 42 43 degrees. So it's a value about. Also, I need to know the distance from all the distance from the pivot point to the corners of my car box, the front and the rear. Then there is the diagonal is a main parameter for this method. I must know that that distance from the rear axle to the front of my car. This is a different size of my car box, and I need to know this diagonal. I will show you why. So the how did I figure out this method? It begins with first the car is already parked. So if I make the movements backwards, I mean the taking out from the parking slot, Um, so if I go backwards those steps, I will get the car in again. It is not so precisely because the Ackermann steering mechanism, we know that, but it works good enough for take this method and calculations. So the final result would give us a car aligned to this to the obstacle in the front, and I mentioned before a diagonal line. This line is important for me because in some moment of the turning, taking out or taking in some moment that diagonal must be exactly parallel to this line. This is a very important parameter for this method. Um, well, after that, the procedure is to get closer to the obstacle or the car in front of us. So then take the full steering wheels and turning in reverse the angle alpha 3. As I said, I am making in backwards steps. So this is the angle alpha 3. Be careful with the contact in that part. And after that, we will move the angle alpha 2 to take out. You know that when you are taking out the parking slot, if this line is free, is not blocked by the car in front of you, then you are free to move out because this line is now um, heading outside space. So now we move the angle alpha 2, and finally the last one will be the angle alpha 1. Remember, this is backwards. So the angle alpha 1 will give us now the initial position to take in the parking slot we already left. So I found the initial separation is about 40 to 70 centimeters. It varies from car to car, of course. The angle sequence in degrees is, in most of the cases, about 43, the alpha 1, about 43, 33 for alpha 2, and about 14 for alpha 3. The length is about 1.4 times the length of the parking car. That's for easy references. The result comes from a set of geometric equations and many car size comparison. Yes. Also, it seems to work in even in large pickups, small trucks, but it doesn't work in heavy vehicles or larger vehicles like passenger buses or trailers or heavy trucks. The values must change from car to car. If you take your own and make the proof and leave a comment, I really will appreciate. So I test in a few cars taken from pages and MathWorks. I take this data and other pages, and I test a few cars just for show the experimental calculations. I get this table. I get there is some data from different cars, size and models, and the calculated angles. The units are in meters and degrees. So these are a few model cars: Chevrolet Camaro for pickup, a medium sedan like a Volkswagen Jetta, the Fiat Panda, Seat Leon, hatchback Chevy Sonic, Honda Civic, and these are the parameters taken. The angle, as I said, is about 42. I use this for my calculation, but it's about 42 or 44. It can change the inner wheel angle. And the results in angles are alpha 1, 2, and 3. You can see it's about 43, 41.5, 43.2, and so on. It's a number about. Alpha 2 is also about 32. Here is the biggest I get, 36, 33, 1, 32, and there is a number about. So you can choose 33 degrees, something about Alpha 3 is also 14. About in this pickup Ford is a number slightly different, but it's a car different. It's a very large vehicle. 14 degrees for medium sedan, and that's about the number I told you, 14. The relation between the length calculated and the car length, it was about 1.4. It's something about in many cases. Well, if you choose 1.5, it's okay. It's more safe in the movement, or even bigger. So this is the results I want to show you. Please leave a comment for me if you can check your own car and test the method, and please give me how it was going. I will really appreciate. Thank you so much.